Next day of neetcode, and we are starting the second day. So let's get started. So I'm sharing my screen. So I'm setting 30 minutes for today, and let's get started. So let's set 30 minutes. Okay, and let's start. So the first easy task. All right, so the longest common prefix. Let's check. Yeah, we see 10%. So maybe in some period of time, I need to stop and charge my laptop. Okay, so we have to write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. So we have a list of strings, and we should return the common prefix or an empty. So here prefix as string, and here like list of strings. So it like double, yeah, list of strings. Okay, I understood the problem. So let's think about constraints. So I would say that array length could be from 0 because we can like 0 strings, and let's say that we have 1 million. What other constraints we can have? So I said I would expect that we have only lowercase English alphabet. Also, yeah, it's not sorted, so it's pretty understandable. So I think that's pretty much all we need here. Let's think about some test cases. So the first test case, so let's say that we have an array of only one string, so we should return an A. If we have, for example, A and B, we also return A. But if we have, for example, C, then we don't have any common substring. So let's create it as a separate use case. So here we have empty, right? Also, I would say that if we have like just empty array, we also return. If we have array with empty string, we also return. Yeah, so something like this, I believe. Let's think about approaches that we can use here. So the first approach, what we can do, we can yeah, so what we can do, we can iterate over our string with two loops. So with first loop, we take first string and we check that all others have some substring, and then so on and so forth. But it would be quite complex one, so write a function to find the longest common prefix. Okay, so what else we can do? So the longest common prefix, it should be the least amount of elements. So if we have, for example, string like this, let's say AAA, then A, and then AA. So the result would be here A, because it's the least, the string with least elements in our array. But how can we make it? How can we make it better? So what I need just to iterate over each of my string and to create some prefix. So how can I do? So when I'm on string AA, so let's say like this. So when I'm on string this one, maybe I can do the following. Maybe So the question, what is the length of I, or the maximum length of this string? If it's like integer, but yeah, we see that the maximum length is 200 elements and from 0. So what we can do, we can take the least element from here, like 200, and calculate a prefix, and then iterate over other strings and check. Yeah, but it would be quite, again, quite the complex. But I want some optimal solution. So, but optimal solution, I believe here it's kind of try, right? So we take this one, then we take this one, then we take this one, right? Then we take the next one. We see that common prefix A. Then we take the next one, and we see that common prefix here and A and A. So we should like build kind of tries here, right? Okay, what if we do the following? What if we first take like from 0 to 200, we have, let's say, a loop from 0 to 200, and then check each index, and if on some index we fail, then we return false. If not, we just collect this substring. Yeah, so it's actually 2 loops. So here it's n, because we need to iterate over each of strings and take an index of this element and compare. So this algorithm actually works with n, because at the top we have kind of a static number of n operations, but let's say it's like 200n, so it's still valuable. And here it's, yeah, let's say it's not n, but like maximum of I, array I. Yeah, so I think it should work. So let's go. So we have like string builder. Oh, let's use like string for simplicity. Then we just iterate from 0 to 200. And here we just iterate over each of our string. And if I is equal to s length, then we return results, right? If not, and we add to our result. So after this iteration, we just add a result. We take, for example, string, like so the first string we can take, for example, take string first one, and we char at I. And here we check if I is equal to s length, or let's say char c. So and here as well, if I is equal to string 0 length, we return result. here we also return result. And here we take char C from the first, from this first string, we take char at I. Yeah, so here we have like 2 times, so we can just add. And here we compare. So if C is not equal to S char at I, we also return results. So actually, it should work like this. So let's do some dry run here. Let's take this one as an example. So we have an empty result for now. Then we iterate over from 0 to 200. So now we are on 0, and we iterate. So we take from here, we take a string I is equal to string length. No. So we just continue. We take A, then we we iterate and check. Okay, char equal to, so we continue. Then we check this one. It exists. So we add A here. Then we go to the next one. We not going out A, and here we see 1, and 1 is equal to length. So we return result from second iteration. So I think it should work. So let's check. Okay, and let's submit. Okay, so we see that operation here is quite slow because we have this string here. If we use string builder, for example, new string builder, and then when we use result, we use here toString. Here as well toString, and here append C. It should work faster. And submit. Yeah, and we see that it's 65%. How it's even can be done more faster? Okay, so they have some preliminary check. They have prefix that they return. Okay. And then if empty, while, yeah, so pretty much the same, right? Pretty much the same that we have. Let's check our previous, for example, submissions. Yeah, so we have this loop, and we have another loop here. Yeah, so we are done with this task. So let's go to the next one with group anagrams. Let's clear this up and let's start reading. Given an array of strings, a group and anagram together, you can return the answer in any order. So we have an array of strings, and we should return a list of anagrams here. And what does it mean, anagram? Anagram is a word or phrase formed by arranging the letter of different words or phrase using all the original letters exactly one. Okay, so let's think about constraints. So we have an array of strings. So let's think about what can be the length of this array. So I expect that it would be from 10 to 6. I also expect that it would be always all lowercase English letters. Okay, and yeah, I don't think that it's pretty much, yeah, I think it's important to think about lengths of each letter. So let's say the lengths of each letter, so we have from 0 to 100. So we have maximum of our array like 100 of one string. All right, so let's think about some test cases here. So the first test case would be the following. So we have an array of AB, then we have BA, then we have CT, and then we have, for example, TT. So in this case, we should return first array of AB and BA, then we have separate array of CT, and then we have an array of TT. So here we see that we actually need to create some key over the same strings. So key actually, if we have only 100, we actually can create our key by using an array of characters for our string. And it's pretty easy to do. So first thing, I think it can be sorting, but sorting here it's not the best approach. So let's think about approaches. So first we iterate our strings and we create a key. So creation of the key is actually an array of static size. Then when we create a key, we should put under this key, we should put in map a list of our elements. So we also need to have a map string to list of strings because we don't know the size of our groups. And after this, we should convert map to list of lists, as we see. And this actually approach works in time complexity. Let's think. So we first iterate over n, then we have the maximum length of our strings. So we have n over m. And also we put this into our map and then iterate our map. So I think it's not complex one. So time complexity n over m and space complexity is n, let's say, because we need to. Yeah, as we see that our stream was stopped because of my perfect laptop. So let's continue. So we see that we have this approach, right? So I'm streaming, okay. So we see that we have this approach with creation key. So what do we need? We need this list. So let's say how much time we need. So 12 list result, new array list. Then we need our map with string to list of strings. So we have our hash map, new hash map. Then we should iterate over our strings. Then for each string we need to create key. So let's have a private function get key from string s. So we introduce our memo with 26 elements. Then we iterate over string with each character es to char array. Then in memo we put c minus a plus plus, and then we have string. Oh, I think it's even better. We can just return arrays to string and memo. Yeah, so 3 lines, we create key, and then we can check if string key get key as if map contains k, then we do like this, map get k, add string s, else map put k new array list list of s. Okay, so we have this map of list of lists. Then we just need to iterate over each of this list and just add to result. So we just add all, and we can do map values and return result. I'm not sure about this line, but let's just go and check how it works. So we have our result, we have map, we iterate over string s, we get key of each of the string s. If map contains, we take this key and add s. Then we add. Okay, so let's start. Okay, and let's submit. Nice. So we solved this question in 2 minutes. So it's pretty fast. Let's check what is the most faster approaches do we have. Okay, so the fastest approach, we see that they still use this map, but here's for each string they create and then they sort. But actually sorting, it's not the most performant because we actually use the same. And then we have normalized key, so the same that we did, and contains key. Yeah, so actually the same, all the same. They just add some shutdown hook, but I don't know like why actually do they need this? It's very strange. All right, so we finalize with this question. It was pretty easy one, so let's go to the next one. So next one is remove element. And let's clean up this first and read our task description. All right, so we're given an integer array nums and integer value. Remove all occurrences of values in nums in place. The order of elements may be changed. Then returns number of elements in nums which are not equal to value. Consider the number of elements in val which are not equal to val bk. To get accepted, you need to do the following thing. Change the array nums such that the first k elements of num contains the elements which are not equal to value. The remaining elements of nums are not important as well as the size of num. Return k. Okay,